Okay, welcome to Wednesday. This is a big lesson, as I said yesterday, and I hope that you got a hold of a graphing calculator somehow, or you downloaded the appropriate app on your computer, or you uploaded the virtual calculator, because I'm going to be doing my graphing calculator in class. If it ends up that I hear back from people that they don't have access to graphing calculator, I think I'll post some links about Desmos, and maybe one day I'll do a lesson with Desmos. But for now, I'm assuming that everyone is in calculator approach. So that's this guy, right? Or you can use the virtual one on your computer. Open two screens if you want to follow along, or maybe not, like probably just open your calculator on the screen and you can just use your hard copy paper book. We have talked about the Cartesian plane. We've talked about displaying data and describing trends, and now we're going to use technology to do the same thing. If I just go back to the assignment, I had assigned lesson 2 to you. There were 3 graphs, and we talked about plotting and let's just do number 1. I'm going to do number 1 the way that you were supposed to do it. Just pen and paper, and then I'm going to do number 1 with my graphing calculator, and then you can see the difference, and then we'll start lesson 3 fresh. So if I look at example 2, the instructions were, and I did erase this out yesterday, I said forget about creating a scatter plot in your calculator. We'll do that in a sec after we do the pen and paper approach. Because once again, you're still going to have to do the pen and paper approach even in grade 12. You're going to have to learn how to transfer your work onto a paper. I'm just going to adjust the camera so that you can see the whole page here, hopefully. All right, draw a sketch of the scatter plot on these below. All right, remember the first column of data is the data that goes on your x-axis. The second is on your y-axis. So my x-axis should be labeled total fat in grams, and my y-axis is total calories. And I guess is just calories, right? That's the unit. So let's see, my minimum is 9. That's my lowest value. My highest value is 34, right? That's my max. So let's see, if I go up by 10s maybe, or by 5s, let's see if I can go up by 5s. 5, 10, 15, 20, 25, 30, 5, 10, 15, 20, 25, 30, 35. That would be nice. In some ways, the smaller increments you can use, the better, because then it allows you to graph a little easier. Remember this corner, this is just a quadrant 1 graph. So this corner represents the origin. Again, this is just dealing with all positive numbers, so I just need a quadrant 1 graph. So that means this is going to represent 5 grams, 10 grams, 15 grams, 20, 25 grams, 30, and 35 grams. And I can see that's going to be enough, right? Because my maximum number of grams is 34. Now on the side here, and this is my highest. They were given to me in order this time, I guess. So this looks like it's a direct correlation, right? As my X values go up, so do my Y's, but let's see what the graph looks like. So I'm going from 260 to 590. I think in this case, I'm going to use one of these, like the slash symbol, because I don't want to start my Y-axis at 0. That would not make sense to me. So let's see, what if I start my Y graph at 550 and I go up by 50s, right? If I do that, or sorry, 250 and I go up by 50s. So I'm just going to start right here. 250, 300, 350, 400, 450, 500, 550. I think I'm going to do that. I'm going to go by 50, 100, 150, 200, 250, 300. Whoops, that doesn't make sense, does it? 253, 350, yeah. 250, 300, 350, 400, See, once you make that slash, you can start at any number that you want as long as you keep consistent thereafter. 450, 500. I think I'm just going to do one of these guys, 550, and I'm just going to extend my line a little higher. 550, 600. Okay. All right, I'll just extend my line. Now I just have to plot this data. So 9 partners with 260. So 9's about here. Remember what we're doing yesterday? We're just kind of spitballing, to be honest. 13 partners with 320. It's about here. 21 partners with 420. I'm going to have to use my ruler here, I think. 21 partners with 420, about here. 31 partners with 560. So 560 is about right up here, right? About here. 31 also partners with 550. So just a little lower. And 34 partners with 590. Okay. Describe any correlation. So as we suspected, and as we probably picked up from the table and you did, there is a positive correlation. As the total number of grams of fat increases, total calories also increase. Okay, sorry about that. Now, as I said, I am going to demonstrate to you very quickly how I do this on the calculator, but just watch me. If you're watching online, just watch right now. There are detailed instructions on the next lesson. I'm just going to show you how technology can make this job a lot easier and a lot more useful to us. So when I have this data plotted, I can quite obviously see that there's a direct relationship, but what I can't see is all I have is information on 6 sandwiches, right? What if I all of a sudden got another piece of info today that told me that the total number of fat grams of, I don't know, something from Burger King has 14 grams of fat. All I have now is I have a pen and paper graph. I could try and figure out where 14 kind of would be on this graph, but again, I'm kind of spitballing here in a pen and paper. With technology, I can give detailed answers to any other fast food sandwich that you throw out at me because I have it all coded in the computer. So what I'm going to show you is I'm going to do the exact same question with a graphing calculator. Okay. So I turn my calculator on and this data is known as statistical data. So I press stat, edit. Okay. Oh, I did the mortal sin of not clearing my calculator. Okay. I'm resetting my calculator like I told you to do. So stat, edit, and I get lots and lots of tables, columns and tables. We're only going to use the first 2 columns. This is my list 1. This is list 2. This is my X value, my Y value. So just ignore the other tables. I'm just going to enter all my X values in first. So I have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And now I cursor over and enter in my Y values. Okay, so I enter my X and my Y. And now I can clear my screen out. And right above the Y equals, remember these are all going to be your graphing tabs. Right above y equals, it says stat plot, and that's what we want to do. We want to take a look at what this plot looks like. So I'm going to turn my stat plot on and get out on the screen again. Okay. And now I'm going to hit graph. Okay. Now I should see my point plots here. And the reason I don't see them is because my window settings, and we're going to talk about that in a minute, my window settings aren't appropriate. Now, remember what we said? My minimum X value was 9. So my X axes were from 0 to 35. My Y axes were from 0 to 600. So I'm going to show you how to adjust the axes on this scale, because the axes on this scale are default to just go up from 10, -10 to 10, -10 to 10. Remember, it's only a quadrant 1 graph. So once again, we only need X values from 0 to 35 and Y values from 0 to 600. So I do that all in window settings. My minimum X value, I'm going to put at 0. That makes sense because that's where my graph starts. And I think maximum, let's put 35. Just ignore scale. Y minimum 0, and our Y maximum, I think we had 600. Okay, now when I press graph, I can see the graph. Okay, so that's pretty cool, huh? Now we're going to do something a little bit different than that as well, but let's try, and that's how we got these graphs at the back. If you look at the answer keys, that's where these graphs came from, right? So what I'm going to do is, because there is no assignment on these, and I guess we should have probably included an assignment, I'd like you, if you have your graphing calculator in front of you, or your virtual app, let's try this. Let's try this second one just using technology. Okay, so clear your calculator. Remember, you go second mem, so go second plus sign, number 7, number 1, and then hit number 2 and clear everything. Okay, so once again, to clear your calculator, you can use, you're just going to use these steps again. So you're going to go second, and then the plus sign, hit number 7, and then hit number 1, and then hit number 2. And that's going to reset everything. So that resets, if you look at your stat edit menu again, that resets all your table up. All right, let's try number 2. Just with the data table, okay? So press stat and press edit, and you get your screen again, right? These are all my X values. So enter those in, 11.9, enter, 14.2, 15.2, 16.4, 18.5, 19.4, 22.1. Okay. And now just hit the side over arrow and enter all your Y values in. 185. Okay, so I have all my values in. I want to see them plotted on the screen, so I have to turn the scatter plot on. Second, hit the Y equals button, and then just press the on button. Okay, you have to make sure the on is highlighted. Okay, now you can just hit the clear button if you want. All right, now remember, if I hit graph, I'm not going to see anything, because remember, you cleared your calculator out, and clearing your calculator always resets this grid to just tens, maximum of 10 and minimum of -10. So let's take a look and see what we should set our graph to. If I was going to do this properly, this graph, let's see. I look at the minimum value and the maximum value. Okay, so this is the max, and this is the min. And here for the y, this is your x and your y, or I guess list 1 as the calculator calls it, list 2. Okay. My minimum y value is, I guess, 185, right? And my maximum y value is 522. Okay, let's see. For x, I'm going to go to my window again. I think for my minimum, I'm still going to use 0. 11.9 is not that far from 0. So whenever I can use 0, I do. And my x, I guess I don't have to use 0. I could use maybe, I don't know, let's use a nice round 150. I always like to go a little lower than my minimum value. If I could use 0, I can, but I think 0s are real far away from 185. So I won't use 0 for my y min. My y max 522, so let's go 550. I tend to use kind of nice round numbers, and whenever I can, I'll use 0 as my minimum. Now this is clearly another quadrant 1 graph, right? Because everything is positive. Let's go 150 and 550. Okay, see how I have to adjust my scales. I don't know if you guys can see that. Okay, now when I hit graph, I should see my nice scatter plot. So even though this involves a little bit of setup with your technology, this is far easier, I think, than point plotting, right? Now notice this is a solid line. This is not a solid line. This is indicating that you're not starting, your y-axis is not starting at 0. This is kind of like floating up, okay? So if I was to, I can clearly see, now if your teacher asks you to plot this, you would still have to plot this on your grid, right? Like you did longhand yesterday for homework. But if your teacher was just asking you what's the trend, I see there's a positive trend, right? Describe any trend. There's a positive correlation. And if you look at the story, now I'm hoping you did this for homework yesterday, so I don't have to recreate this graph. But if you look at the story would be, well, let's see, what was happening here? Temperature, ice cream sales, I guess. And this makes sense. As the temperature rises, ice cream sales also rise or increase, right? And that makes perfect sense. Okay, let's try this last one before we move on to today. And I don't see any questions, so I'm going to keep going on. Okay, clear your calculator out. Remember, these are the steps to clear your virtual calculator out. So we're going to go second plus sign, then number 7, hit enter, number 1, whoops, 7, number 2, oops. Let me do that one more time. Number 7, then number 1, then number 2. So it's all cleared, right? So these are your instructions. Second plus sign, number 7, number 1, number 2. So everything's cleared. So once again, if I tried to press graph, nothing would show. My calculator's been cleared. So let's try this last one just to get practice on entering data in. So this is my list 1, right? List 2, X, Y. Your calculator doesn't call them X, Y, it calls them list 1, list 2. So I press on stat, and I'm going to enter all this data in. and then this list of data in. Okay, so I want to show a scatter plot, all the dots. So I have to turn my scatter plot on, max value, and a Y min value, and a Y max value. And remember, that's under, just going to write you a little note, that's under Windows. Change Windows. Windows is another word for your axis settings. So let's see what my lowest X value is. They're not always in order. So this is my lowest X value, min. And my highest X value seems to be this one, right? Max, right below it. And my lowest Y value looks like it's this one, right? And my highest Y value is this one. So let's see, 144 to 195. How about we go, I don't know, how about we go 130 and 200? And then for Y min, I don't know, you want to go 40 again to, how about at 100? Okay. Now these are arbitrary. You can change them. You could certainly start at zeros. But if we just want to see a scatter plot, we can just use the data given. Remember, X min is your lowest, and then just use your cursor arrows to scroll and then hit graph, right? And sure enough, we see these. Now we should see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 coordinate points. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So they're all displayed there. And this data is not as uniform as the previous data that we had. That's for sure. It is more scattered, but I still see to me, I still see a positive correlation, a little bit of one. It's a little more scattered, but I still see a bit of a trend up. It's not as strong as the last one. And hopefully if you did this by hand yesterday, you would have your own data plotted here, but I would still say there is a positive correlation. And again, as height increases, weight increases. That's not always 100% true, right? Not every person with the same height has the same weight, but if you think about a baby, obviously a 10-year-old child weighs more than a baby. A 10-year-old child is taller than a baby, so that makes sense in general terms. I would say that generally speaking, someone who's 6'5" would probably weigh more than someone who is only 5 feet. Again, that's a general. Okay, I don't see any questions. So this is basically, we were just using technology data, and I was going to start the next lesson today. This is a big lesson, so I actually might chunk it up a bit, and I'm going to do a little bit today and a little bit tomorrow. So let's take a look at, this is a repeat of what I was just doing, okay? But instead of just plotting a scatter plot, we actually want to go to a scatter plot, which is the big reason why we're using the graphing calculator. When we plot a scatter plot, we're only getting information on these 10 points, but what we really want to do is get information on the whole relationship. If I just go back for a sec, sorry for all the page flipping. If I go back for a sec, really what I'm using data and technology for is not to get information on these 10 people, but I want to take the information that I learned from these 10 people and I want to expand and come up with a general rule. Because what if someone comes into the class next or into the club next year who isn't one of these heights? I want to make a prediction about the weight. Or this is a bit of a trivial example, but how medical people use this, or doctors, they use a bunch of heights of babies or lengths of babies, and they, data from millions and millions of babies, and they come up with how much a baby should weigh depending on their length, right? And that's how they judge if babies are growing at the right rate. So this is exactly how doctors have established norms for babies, and that's why people take their babies into the doctors for regular checkups, especially in that first year, because they're constantly checking their length, which that's what we call a baby's height, their length, to their weight. And if the baby is not following the normal pattern, then there's cause for concern and they might do some further tests. So once again, if I just have information on 10 babies, that's not really a lot, but in databases, they have information on millions of babies, and they create a scatter plot. And from that scatter plot, so in essence, this scatter plot, they would come up with a general rule. And what that general rule is, it turns it into an equation. And we know once we have math equations, we can use them to solve for lots of things. So that's what assignment 3 does. Assignment 3 is taking scatter plots and turning them into equations. So if we just read a few of these words, it says there are many types of relationships between two quantities. So anytime you have an x and a y, or list 1, list 2. In the second paragraph, finding equations that match real-life situations is called mathematical modeling. Math models are used in physics, bio, etc., etc. Mathematical models help to describe and explain situations and are used to make predictions. We're taking our scatter plots and turning them into equations so we can make predictions. When we develop an equation, we can use it to predict additional values that aren't on the initial table of values. So when a scatter plot shows a linear pattern, we can develop a linear equation to model the situation. So we're going to start slow. I'm going to do this first example, and then I might maybe try a second one. I don't know. We'll see. And then I'm going to leave you to play for the rest of the day and maybe perhaps come back tomorrow and ask me questions. So this table shows some data collected regarding the relationship between the size of a house and the price of the house. Okay? Determine the equation. So notice, determine the equation that models this situation. Okay. So first thing we're going to do is we're going to take our calculator and we're going to turn it on again, and we're going to clear everything out. So second plus sign, number 7, number 1, so hit enter, and then number 2, hit enter, and everything's nice and cleared. So you can see when I go to my stat, so once again, I'll slow down. Once my calculator is clear, I have statistics to enter in, so I hit the statistic key, and then I want to edit just means enter, okay? Like you're going to enter data in. All right, so this is my list 1, list 2. This is your X variable, right? Your Y. But the calculator calls them list 1, list 2. Okay, so list 1, I'm going to enter 1150. And then I'm going to jump over. Now these are large numbers, so I think I'm going to try just to enter the large numbers in. And we'll have to make sure we adjust our windows, right? Accordingly. 265, 349, 440, and 499, 950. Okay, so my data is entered. If I want to see the data, I have to do 2 things. I have to turn my scatter plot on. So highlight on. Again, that second y equals right above where it says stat plot. And then remember, we also have to adjust our windows. So let's take a look at our windows here. This is my smallest, right? This is my min, my smallest. And this is my max. This would be my minimum y value, I guess, on the chart. And this is my largest y value, max. Okay, so I'm just going to, again, this is something I always do, and I'm going to encourage you to do. We're going to plot. I'm going to write down x min, x max, and then y min and y max. Okay, actually, I'm just going to move my x min, x max over a little bit. Now, this is arbitrary, meaning there's more than one answer. You could put zeros in here. I see this is all positive, but that would make the graph look a little funny. So let's see. My smallest number is 1150. So I think I'm going to use 1,000 as my minimum. And then I think for this one, I might use 3,000. Okay. So they're nice round numbers. Here, 265. So I think I'll use 250,000. as my Y min. And for my Y max, I don't want to just stop at 500. Maybe I'll use 550,000. Okay, so I'm adjusting my windows. You have to use window settings that fit your data. Okay, so Y or X min is 1,000. X max is 3,000. Y min is 250,000. And Y max is 550,000. Okay, and I should be able to see my graph now. Now I should see 1, 2, 3, 4, 5 points. 1, 2, 3, 4, 5. Okay, so there's my screen. All right, nothing different from what I had done before. Okay, so at this point, we're just repeating what we did on the previous lesson, but now we're going to take this and turn it into something much more powerful. We're going to take a scatter plot and turn it into an equation. Okay, now it says for part A, determine the linear regression equation that models this data. Instructions are found on the next page. So if you move to the next page, you'll be able to see all the instructions. So when you go back today, if you want to review this lesson, you can review my words and my steps. They're all displayed here for you too, right? So press the stat button, choose edit, and enter all your data in. Okay, well, we've done that already, right? Now, after you've entered your data in, they don't tell you to look at your stat plot. Well, I'm looking at my stat plot. So now what we're going to do is we're going to go back to the stat, okay? And you can see, press the right arrow key to highlight calc, okay? We want the calculator to calculate our data, okay? So we're going to hit the calc screen. Once we hit calc, or we highlight calc, you'll see another menu drops down. Once you have cursored over to highlight calc, from that menu, choose number 4. Okay, so press stat, highlight calc, then you're going to choose number, should have X'd this out. You're going to choose number 4, linreg. That stands for a linear regression. And that's what we have here. Like, we want a linear regression, a straight line graph. That's what your data asked for too, right? It said choose linear regression, okay? So that's number 4. You can either just press on number 4 or you can cursor down to number 4 and hit enter, okay? Now you're going to get this screen. Okay. Now, once you get this screen, you've got some information the calculator's telling. We're not doing a frequency list. That's something a little different. So just bypass that. And you want to store this, you want to store all the data, store regression equation. This is allowing you to store all your data and create an equation. So we're going to stop here. You can see the little cursors right here. Okay. From here, we're going to press the vars to y. Okay. We're almost done. Press enter twice, and you'll see why in a moment. I press enter, and then there's something called, there's all these y equals statements. So you want to press enter again, okay? And now what you've done is you've told the calculator to enter all your data into your Y1 screen, and that's what you really want, okay? So once you're done this, that's it, you're done. Now you're gonna select calculate at the bottom. You're done with this menu. You just have to move down to calculate. And there we go. There's your regression equation, okay? Now it might not mean anything to you, but it says calculate, use calculate option. You'll be taken to a screen with information about your regression equation. So this is your regression equation, okay? This is what your question asked you. Come up with the regression equation. Now the equation of a line, this is what the equation of a line is. It's in this form. Y equals AX plus B, right? They're asking you, they're saying A equals 191.84. They're giving you this data. And B equals 3690.01, right, if I round properly. So this is the info they gave you. Now, your equation is okay. I have to substitute the A in where A is and the B where B is. So Y equals 191.84x plus 36902. That's what they asked me to do. Now, this is much more powerful than just having a stat plot. And I'll tell you why, because once we have all this information in, okay, something interesting happened to your graph. When we went into all this detail and we went through this new screen, we don't just have, I'm going to show you something. So this is where you are right now, right? Your calculator gave you the values for A and B. Okay, and this equation of a line has to maintain its Y and X. This are allowing us to put it on our Cartesian plane. Okay, so it took all this data, and something really interesting happens. When we press graph now, not only do we have the scatter plots, the points plotted, we have this line going through. This is the line of best fit. This is the line that models the relationship that we can use to make predictions. Remember I said if we only have information about 4 or 5 or 10 little babies, be able to make predictions for millions. So that's what this line does. It allows us to make predictions in the future. Now, we're not talking about baby weight or height right now. We're talking about house size and size. But this, I'll show you what the beauty of this is now. So it says, use your equation to determine the price of a house that's 2,000 square feet. Okay, well, if I look and I see 2,000 is not indicated on my screen, but once I have this regression equation in, it's very easy. I can just press the trace button and I can move my cursor up and down. Whoops, trace. Okay, sorry. press your trace button, and then hit the up or down arrow, whoops, until you see your y equals screen, okay? Now see what happens? I can make predictions up and down the line. So when X is 2,000, I can see what my price is, okay? Use regression to determine the house is 2,000. So when X equals 2,000, remember that's the size of your house. House size is 2,000 feet squared. Y equals, okay, what was that answer again? 420,584.36. And remember what Y stands for. Y stands for the price. Okay. So see how this is so much more powerful than just those 10 little plots that we had plotted like from the previous lesson. Let's try this one. Determine the price of a house that's 3,400 square feet. All right, let's use the trace button again. Make sure you're on the Y equals line. When you bounce up and down like this, right? When you bounce up and you see only L1, L2, they're just gonna bop you from point to point, right? And you don't want that information. You're done with the point-to-point information. So use the cursor arrows to go up or down. You actually want the line, the equation for the line. Okay, so I'm using my left and right cursor values. And let's see if we can find 3,400. Okay, so what's happening? I'm frozen. I'm frozen at 3,000. Okay, and the reason I'm frozen at 3,000 is, remember we set our maximum X value to 3,000. So let's do this for this question. Do 5,000, let's say. Okay, so I'm going to, right? I can only go as, my screen's only letting me go so far as what I set it at. So I go back to window. Let's change this to 5,000. Now if I hit graph again, my graph's going to change slightly because I changed windows, but let's hit trace again. Let's make sure we're on our Y equals. Let's see if we can find 5,000. Or sorry, it wasn't 5,000, it was 3,400. Oops, and I can't quite get 3,400. Okay, so that's a bit of a problem. Okay, I'm close. I'm going to show you another couple of other ways to do this. When you can't get right on, go right on to the 3,400. Okay, there's another way. It's actually a better way that I can do this. So I'm going to go back to my second calc menu. And I'm going to press option 1, and I'm going to show you something beautiful here. That option lets me put in any value I want for X. So I could just put 3,400 in, and there's my perfect answer. That's actually a way better system than trace, but I wanted to show you trace first because trace is really intuitive, right? So we can use trace, but the better way is, okay, so I'm going to write these instructions down for you. You're going to go second and then trace. Okay, so second, trace, and then choose number 1. As soon as you choose that number 1, it's going to make perfect sense what to do because it asks you what you want X to be. You can put in anything you want for X, right? We wanted 3,400. So Y equals 6, okay? So the price, of a 3,400 square foot home is 689,162.01. Okay. I know that was a lot to take in, so I think I might actually leave it there for today because I see that it's 1:45. I want to show you one other thing though. This is the best way to find y values if you're given x's, right? Trace is okay, but it takes a long time too. But I'll just show you something I could have gone second calc value, and I could have just put a 2,000 in here, right? And I still would have got the same answer. See? So this is the better way. Some students like trace, and because it's really easy, you just trace and you go up and down and you can see the numbers changing. But the best way is to use this method. So just go second. I'm just going to let you look at this and try that question again. And what you could do, you could try example 2 and 3 for homework because the answers aren't given. And then maybe tomorrow I'll give you some work time to work on assignment 3. And I'll show you how that'll work. I'm going to try and set up a Google Meet room for you. I'm sure that you're going to have questions for me. So what I'm going to do is I'm going to sign off. If I don't hear from anything during over live chat, I'm going to sign off. I'll post all the notes on the blog. I'll post the video on the blog. You can watch it over again. That's the beauty of the video lesson. You can watch it. And once again, you can always email me if you have questions, connect with me that way. Or like I say, I'm going to set up maybe a Google Meet for part of the class tomorrow even, if we have time for that. So